Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is solving quadratics with square roots. The first thing we need to look at is the product property of radicals. The product property of radicals says that the square root of a times b can be rewritten as the square root of a times the square root of b. That may not make sense to you right now, but it will moving forward, okay? The first thing we want to do real quick is make a list of perfect squares. The perfect squares that we are really going to focus on are 1, 4, 9, 16, 25, 36, 49, it would be 64, 81, 100, 121, 144, 169, 196, and 225. Now, what you need to know is what the square root of each one of those numbers are. So, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, of 16 is 4, 25 is 5, 36 is 6, 49 is 7, 64 is 8, 81 is 9, 100 is 10, 121 is 11, 144 is 12, 169 is 13, 196 is 14, and 225 is 15. So my actual perfect squares are the 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Their square roots are the numbers that I have in parentheses below them. So what we're going to do is we're going to take the numbers that are inside the square root. We're going to see if they are divisible by any of our perfect squares. If they are, then I can rewrite my square root as the square root of that perfect square times the square root of whatever is left over. So the number 20, I want to look at my list. I want to find the next largest perfect square, so that would be 16. 16 is the next largest perfect square. I'm going to see if 20 divided by 16 comes out to a whole number. It does not. So then I will move to 20 divided by 9 and see if that would work. Again, it will not. So I will try 20 divided by 4. Well, 20 divided by 4 will work. So I can rewrite this as the square root of 4. We found out that 20 divided by 4 is 5. So that is the square root of 5. So the square root of 20, or this right here, the square root of a times b, can be rewritten as the square root of a times the square root of b. That's what we did in problem number 1. We have rewritten the square root of 20 into the square root of a times the square root of b. In this case, it would be the square root of 4 times the square root of 5. All right? From here, I want to see if I can take the square root of something. Well, the square root of 4 is perfect, so it would be 2. The square root of 5 will not be perfect, so I'm just going to leave it as the square root of 5, and I am done. So now on to number 2. I want to see if there is a perfect square a perfect square that is perfectly divisible from 48. So the first number I'll look at is 36. Is 48 divided by 36 perfect? It is not. Is 48 divided by 25 going to be perfect? It will not be perfect. What about 48 divided by 16? That will come out to a whole number. So I can rewrite that as the square root of 16 times the square root of 3. The square root of 16 is 4 times the square root of 3, because 3 is not a perfect square. That is my answer. All right, let's look at number 3. I have the square root of 49. Is 49 on my list? Yes, it is. What is the square root of 49? It is 7, so I am done. On to number 4. I have the square root of 63. So the first number I'm going to check, I'm going to take 63 and divide by 49. That will not come out right, or as a whole number. 63 divided by 36 will not come out as a whole number. 63 divided by 25 will not come out as a whole number. 63 divided by 16 will not, but 16 divided by 9 will. So I can rewrite the square root of 63 as the square root of 9 times the square root of 7. The square root of 9 is 3. The square root of 7 is not a perfect square. So I'll just leave it as the square root of 7. On to number 5. I have the square root of 50. So the first number I'm going to check is 49. So I'll take 50 divided by 49. That does not come out to a whole number. Then I would take 50 and divide it by 36. That also will not come out to a whole number. But 50 divided by 25 will work. So I can rewrite the square root of 50 as the square root of 25 times the square root of 2. So the square root of 25 is 5. The square root of 2 would not be a whole number, so I'll just leave it as the square root of 2. On to number 6. Here I'm looking for the closest number to 32 out of my perfect square list. That would be 25. So I'll try 32 divided by 25. It will not work, but 32 divided by 16 will. So I can rewrite that as the square root of 16 times the square root of 2. That would give me 4 root 2, and I am finished. On to number 7. Number 7, I'm going to look for the perfect square that is closest to 44. The first one is 36. 44 divided by 36 will not come out to a whole number. 44 divided by 25 will also not come out to a whole number. 44 divided by 16 will not. 44 divided by 9 will not. But 44 divided by 4 will come out to a whole number. So I'm going to leave my 3 out front. I'm going to rewrite my square root as the square root of 4 times the square root of 11. Okay. Now I can take the square root of 4, so I'm going to leave my 3 out front. I'm going to multiply that by the square root of 4, which is 2, and that will be multiplied by 11, the square root of 11, because the square root of 11 is not going to be, or 11 is not a perfect square, so I'll just leave it as the square root of 11. Well, 3 times 2 would be 6 times the square root of 11, and I am finished. On to number 8. I will check my list for perfect squares and divide them from 54. So I'd take 54 divided by 49. That will not work. 36 will not work. 25 will not work. 16 will not work. But 9 will. So again, I'm going to leave my 8 out front. Rewrite my square root as the square root of 9 times the square root of 6. Well, 9, the square root of 9 is a perfect square, but the square root of 6 is not. So I'm going to end up leaving the square root of 6 as just the square root of 6. The square root of 9 is 3, so it would be 8 times 3 times the square root of 6. 8 times 3 is 24 times the square root of 6, and I am finished. Okay? On to number 9. I'm looking at the square root of 18, so I need to look at the largest perfect square, or the perfect square that is closest to that. It would be 16. I'd take 18 divided by 16 in my calculator, see if it comes out to a whole number. It does not. The next one is 9. That will work, so I keep my negative 2. Rewrite my square root as the square root of 9 times the square root of 2. The square root of 9 is 3, so I'd take negative 2 times 3. The square root of 2 will not be a whole number, so I'll leave it as the square root of 2. Now I just need to take negative 2 times 3, which is negative 6, times the square root of 2, and I am finished. All right. On to the quotient property of radicals. The quotient property of radicals says that if I have a fraction under one square root sign, so this right here, then I can rewrite the fraction as 2 separate square roots. All right, so let's look at number 10. I have a fraction under the square root sign, so I can rewrite this as the square root of 4 over the square root of 9. Now, is 4 a perfect square? Yes, it is, so that would give me 2. Is the square root of 9 a perfect square? Yes, it is, so that will give me 3, and I am finished. Okay, on to number 11. I have a fraction under the square root. I can rewrite that as the square root of 11 over the square root of 16. Is 11 a perfect square? If I type the square root of 11 into my calculator, does it come out to a whole number? Well, it will not. So I'm going to keep that as the square root of 11. The square root of 16 is 4. And so I am done. On to number 12. Sometimes with the fraction underneath a square root sign, I need to see if I can simplify the fraction. In order to simplify the fraction, I will look for something that they are both, the numerator and the denominator, are divisible by. In this case, they would both be divisible by 5. So if I take 140 and divide by 5, I'll end up with 28. If I take 45 and divide by 5, I will end up with 9. That is still going to be under 1 square root. From here, I can take and make 2 separate square root problems. Now, looking at the square root of 28, I'm going to look at that the same way I did on the stuff above, where I have a possible perfect square that is divisible from 28. Well, if I take 28 and divide by 4, I will end up with the square root of 4 times the square root of 7 over the square root of 9. From here, I can take the square root of my perfect squares. So the square root of 4 would give me 2 times the square root of 7, because that is not a perfect square, over the square root, or over 3, because that is the square root of 9. That would be the end of my answer, and I am good to move forward. On to number 13, we're back to just looking at two numbers that we cannot simplify our fraction, so I can rewrite them as 2 separate square roots. Should be the square root of 5 over the square root of 9. The square root of 5 would not come out to a whole number, so I'll leave that as the square root of 5. The square root of 9 would be 3, and I am done. On to 14. Again, we want to try and simplify our fraction if possible. I can looking at 32 and 50, I could tell you right now for sure that they are both divisible by 2. So if I divide 32 by 2 and 50 by 2, I will end up with 16 over 25, which is still under 1 square root. From here, I can go ahead and split them into 2 separate square roots. Is 16 a perfect square? Yes, it is. The square root of 16 is 4. Is 25 a perfect square? If you're not sure, look back up at our list that we made earlier. Well, yes, it is, and the square root of 25 is 5. On to number 15. The 2 out front, I'm just going to leave alone for a few minutes. So I'm just going to write 2. I have the square root of 36, or the square root of 36 over 49. Those are both perfect squares, so I don't want to try to simplify those. But what I will do is split them into 2 separate square roots. Okay? What is the square root of 36? It would be 6. The square root of 49 would be 7. Now, I have 2 times a fraction. In order to multiply a whole number by a fraction, what I can do is I can put that into a fraction of its own, which is 2 over 1. To multiply fractions, I multiply straight across. That would give me 12 over 7. And I am finished. On the back. On the back it says solve the following quadratics by using square roots. Make sure your answer is in simplified form. So what I'm going to do is I need to get the x squared by itself. On number 16, the first step to that would be to add 49. That would give me x squared is equal to 49. I can take the square root of both of those. That would give me x equals, if you type that into your calculator, it will come out with just the answer 7. However, and we've talked about this before, the square root of a number is not just the positive. Type -7 times -7 into your calculator. What you end up with is positive 49. So this would be the positive and negative of 7 would be my final answer. If you remember from what we talked about in the last unit, if there's a 2 for my largest power, then I should have 2 answers. Well, positive 7 and -7 are 2 separate answers. Now, if you also remember from our previous unit, I could have factored this. That is the difference of 2 squares. I could have factored it. You do not need to write this down, just pay attention. Into x plus 7, x minus 7, and that would be equal to 0. I could set x plus 7 equal to 0 and x minus 7 equal to 0. So x would equal -7 and x would equal positive 7. That is another reason why our answer needs to be plus or minus every time that we take the square root of a number. All right? On to number 17. The first step in order to get x squared by itself in number 17 is to add 36. That would leave me with 2x squared is equal to 36. Now I would divide by 2 on both sides. So x squared would equal 18. Take the square root of both. Again, guys, getting the x squared by itself is really just review on solving for x from Algebra 1. That's why I'm kind of going through that fairly quickly. But from here, what I will do is slow down. I'm looking at the square root of 18. Can I break up the square root of 18 into a perfect square and another number? I can. It would be the square root of 9 times the square root of 2. The square root of 9 would be plus or minus 3 times the square root of 2. And I am done. 3 square root 2 is actually all one number. If you type in 3 square root of 2 into your calculator, or 3 times the square root of 2 into your calculator, it should end up with the same number as if you typed in the square root of 18. All right. On to number 18, let's go ahead and add 16. We'll have 2x squared is equal to 16. Here again, I'm going to divide by 2. So that would give me x squared is equal to 8. Take the square root of both sides because the square root is the opposite of squaring something. That would leave me with x equals. Can I break up the square root of 8 into the square root of a perfect square and the square root of another number? Yes, I can. It would be the square root of 4 times the square root of 2. Well, the square root of 4 would be plus or minus 2, and the square root of 2 would stay. All right. On to number 19. The first step here would be to add, would be to add 4 over 9 to both sides. That would leave me with x squared is equal to 4 over 9. I'm going to take the square root of x, which is the square root of that whole fraction. So x would equal the square root of 4 over the square root of 9 because I could break up my one fraction inside of a square root into 2 separate square roots like we did on the front problem. The square root of 4 would be plus or minus 2. The square root of 9 would be plus or minus 3. So my answer would be plus or minus 2 over 3. On to number 20. I'm going to go ahead and add 2. That would leave me with this square, or x squared is equal to 12. Take the square root of both. X would equal. Now the square root of 12, can I divide that by a perfect square? I can. It would be the square root of 4 times the square root of 3, which would leave me with x equals plus or minus 2 root 3 because the square root of 4 is plus or minus 2. That is the end of our lesson. The most important things from this lesson are to start memorizing that perfect squares list as best you can. All right, that's the first thing. You need that list. All right. The next thing is if you have the square root of a number, you can break it into 2 separate square roots that are multiplied by each other. You obviously, if you break it up, you want to break it into the square root of a perfect square times the square root of another number. Also, if you have the square root of a fraction, you can break that into the square root of the numerator over the square root of the denominator, or just basically 2 separate square roots. If you have any questions over this video, please make sure you either come in before school or ask me during class. Thank you very much for watching this video, and have a great day.